Objective 14, discuss formation and effects of acid deposition, contrast it to acid rain and state ways of prevention. So there's a lot here. This is basically section 5 of your chapter 8. So acid deposition is a broader description or definition of any process where acidic precipitation is removed from the atmosphere. So this can be rain or sleet or snow or rain, but it can also be dry. So we talk about wet versus dry acid deposition. So what would dry acid deposition be? This would be like if you have dust or smoke settling out, maybe from a volcanic eruption or some kind of a fire, which ended up with an acidic component to it. So little bigger idea than just acid rain. So what are causes of acid rain? Well, first of all, you have to realize that when we talk about acid deposition or acid rain, we're talking about a pH that's less than 5.6 because naturally rain does pick up some acidity due to the carbonic or CO2 dissolving in it to form a weak carbonic acid. So causes are going to be things like SO2 from coal is a big one. And your equations are going to be that sulfur plus oxygen gives you the SO2. And then SO2 can combine with H2O to give you H2SO3, which is sulfurous acid. Or the SO2 could combine with O2 to form the SO3, which then combines with water to give you H2SO4. And I'm not going to type up all these equations because you can certainly look at it in your book. But the second big category is the nitrous oxides, and this is from cars' engines. And normally oxygen won't combine with nitrogen because nitrogen is fairly non-reactive, but the high temperature that cars burn at allows the NO to form. And so N2 plus O2 can give you the NO2, or N2 plus O2 can give you the NO. So we have both NO and NO2 forming from cars' engines. So sometimes we just refer to this as NOx, meaning that it could be both NO and NO2. So then what are the effects of it? Well, let me just cut this and go to a new slide so we have some room for things here. There's all kinds of effects. There's effects on specifically on CaCO3, which is calcium carbonate, but it's found in marble and in limestone. So both in natural formations and in a lot of buildings and statues, etc. And the big effect on CaCO3 is both sulfuric and nitric acid, being strong acids, react to form calcium sulfate or calcium nitrate, which are more soluble than the CaCO3. So what that means is now that your calcium carbonate is being replaced with calcium sulfate or calcium nitrate, you're going to start seeing your statue wash away as it dissolves in the water. Other effects of this that we see is it promotes more rusting and just metal corrosion in general, which isn't great if you like your car to have a nice coat of paint on it. It also, so it removes protective layers from metals. It encourages more rusting. Another problem is with plants, it leaches good ions like Mg, 2 plus, Ca 2 plus, and I can't remember, oh, potassium, the other thing you find in fertilizer. Those leaches those good ions out, which are all important for plant growth, so it harms plant growth. It also releases aluminum 3 plus. Oops, I thought I had it up there. Which causes damage to plants. So Al3 isn't good for it, but it releases that. The Mg, Ca, and potassium ions that it needs all get leached away or taken away. Water, obviously, is going to become acidified. And that can be unhealthy for people to drink. It can be hard on the aquatic life, both plant and animal. A more direct effect on humans is respiratory problems are common. Okay, so those are some of the effects. So let's talk about prevention. Let me get another slide here. I'll just duplicate this one and take the effects off. So how do you prevent it? Well, the two big things to prevent are prevent the SO2 from getting into the atmosphere and prevent the NO from getting into the atmosphere. So how do we do that? Well, SO2 you can prevent before you use it. We call that pre-combustion. You can just crush and wash your coal. If the sulfur is in the form of a metal sulfide, because metal sulfides are going to be heavy and they'll sink to the bottom, and you'll be able to separate the sulfur out and then go ahead and use the coal for its intended purpose. Another pre-combustion method is something called hydrodesulfurization, and it's kind of what it sounds like. Let me just separate these here. So the other one is hydrodesulfurization. Do I have that right? Desulfurization. And again, you react the sulfur with hydrogen. So this is when it's in its pure form instead of being a metal sulfide, so you can't just crush it and wash it. So you've got the sulfur in its elemental form. You go ahead and react it with hydrogen to form H2S and remove it from the coal. And then we can actually use the H2S to form H2SO4 sulfuric acid, which is one of the most commonly used acids in all of industry. There's also an option to remove SO2 post-combustion. And the common way to do that is called flue gas desulfurization. Now, if you've read any of the Harry Potter books, you know the flue is the chimney. So we're talking about the smokestacks that you see around a coal burning plant. And so what they do is take the sulfur out of the gas as it's moving up the smokestack. And what they do for that is they usually use a slurry of some calcium oxide and calcium carbonate, because as you remember, the sulfur can bump off the oxygen or the carbonate, and then that will remove the sulfur from the air and release less harmful things in its place. And again, you can get a lot more information on this from your book, but this is just kind of the quick skinny on these big topics. So how about prevention of the nitrates? Well, the nitrates, there's no pre-combustion, let's say NOx, because it's the result of combustion in your car's engine that forms the NOx, either NO or NO2. So there's really two big ways to prevent it. Both are going to involve removal, so post-combustion or burning. And one is really quite simple. Just use a lower temperature combustion in your car's engine. Now, that sounds pretty easy, but it's a little harder to do. So far more often is to use what's called a catalytic converter. And you maybe have heard of that on your car. It's part of the tailpipe. As the gases move from the engine out to the muffler, they go through a catalytic converter. And the idea with the catalytic converter is it has a catalyst in there. I believe it's platinum in there. And it converts both CO2 and NO back into less harmful things. Specifically, it's going to take 2 carbon monoxide, which carbon monoxide is not the best thing to be forming for the environment. And it could take 2 nitrous oxide and convert it back. Let me get my arrow here. To just CO2, which although it's a greenhouse gas, it's better than CO. And then N2, which is what most of the atmosphere is made up of. So those are some prevention ideas for the sulfur dioxide and the nitrous oxides.